we use simple exponential smoothing when there is a level, but there is no trend and no seasonality. And today I'll be going into the next topic. And till then, which was uploaded in the previous lectures also. So look into it. And today I'll be starting with, of course, I covered this in the previous video also. Why it is called simple exponential smoothing? Because we give higher importance to the components that are very near and lower importance to the components that are behind. So, like the equation you can see here, the constant alpha is used for giving that weightage factor. It is like a weighted average. More weight is given for if there is a time series, and more weight is given for things that are closer, and less weightage is given for things that are far away. And why it is called exponential smoothing? How did I get it to be exponential? That's what this too I have explained in my previous class. So for LT minus 1, I'll be substituting the same formula, the same expression in the place of LT minus 1. So it will become alpha yt minus 1 into 1 minus alpha into t minus 2. This is the same. I'm substituting this one over here in the place of 1 minus of t minus 1. So it becomes t minus 1, t minus 2. And likewise, I can go on expanding it. And after expanding it and removing the common, we see that the weights exponentially decay into the past. It becomes 1 minus alpha, 1 minus alpha square. So as the expression goes up, the weightage for the nearer components is increasing exponentially. So nearer components are given more importance. That's why it is called exponential smoothing, as the weights exponentially decay. Okay. Then about these are some of the notations that I will be following in today's class. So L is the estimate of the period, and T is the trend, S is the seasonality, right? And F is the forecast of demand. If there is some demand for what I demand, in the sense it is the like some behavioral attribute, and the time is of course the contextual attribute, and the rest is the behavioral attribute. It can be demand or temperature or whatever it is. We have it as demand over here in general. And then alpha, beta, and gamma are the three components for which for alpha is used for. We saw three techniques, right? Simple exponential smoothing where there's no trend and no seasonality. Then when only there is trend and no seasonality, and the trend and seasonality. So if there is a time series like this, which time over here, so this shows the level of the time, right? Then trend is whether we follow a rising or a falling trend. So let me say this is a time series with a trend, right, at level 3. And then there is and then this captures the level. Then if there is a seasonality, there is some particular rise or fall at particular periodic cycles or non-periodic cycles. So it is like, if something happens like this, then we say that there is a level and a seasonality. Level, this is the level, this is the trend, and this is the seasonality component. Okay, and the seasonality occurs at definite time, irregular or irregular time periods. This is what it's all about. In my previous session, I would have clearly explained that. So when we are having values with trend and seasonality, then we go for Winter's exponential smoothing, simple exponential smoothing. Then with the trend and no seasonality, Holt exponential smoothing, and with the trend and with the seasonality, we go for Winter's exponential smoothing. These three components are simple exponential smoothing has a factor called alpha, or a weighing factor that has alpha for controlling the trend level, and Holt exponential smoothing has something called beta, and Winters has something called gamma. So these are the three parameters that is going to control the way your smoothing algorithm is going to work, and how efficiently it can be used for prediction. Okay, that's what is alpha, beta, and gamma over here. So it is used for level, trend, and seasonality. And the three values range from 0 to 1 typically. And ET is the error forecast. And generally, we in our problems will be using the value of t plus 1 or t. So if it is t plus 1 here, we'll be having t over here, LT. LT is going to be a forecast of the thing will be the current level plus the alpha into the next level, expected minus next level. And this next level will be the forecast of the previous one, right? And the forecast will be adjusted using the forecast error. We'll see how to compute all these notations in a small example in the coming slide. Likewise, this is for no trend, no seasonality, and this is with trend. So trend is captured by using this parameter beta. How do I remove the trend out of the series? By single differencing. How do I remove the level out of I remove the trend using single differencing. I remove the seasonality using double differencing. Yes. So single differencing, I can remove the level, and by double differencing, I can remove the seasonality. And by using the appropriate lag of differencing, I can remove the seasonality if it is a periodic season, right? So for a time series under study, if your season is going to be the periodicity of the season is going to be even, then we use a particular deseasoning formula. And if your period is going to be odd, then we have a separate deseasonalizing approach. So it's not quite different from each other. The thing is about how you calculate the difference. Like if you have a seasonality, and of course you have a trend, right? So if there is a trend and there is a seasonality, then you need to capture the difference or the lag in the seasonality here. So that is what we use it for even and odd computation. That difference is captured in that approach. And then after computing the deseasonalized difference uh, trend, then we use for calculating the level, and then for we go for forecasting. I'll show you an example now. The same formulas I have over here, I'll tell you when it is applied. I have here the weeks and the demand of an article, right, for the week. So how can I get how many weeks are there, what are the periods, or what is the seasonality? How can I know it? If it is just like this, I can see it and understand. I cannot see and understand. I need some form of visualization to find that. So you can see over here for the time period over a period of 16, this is the kind of demand and trend demand I have, right? So what do you observe over here? Is there a level? Is there a trend? Seems to be a rising trend, right? Something like this. Okay. And is there a seasonality? Yes, there is some kind of a seasonality that occurs over a period of time. So this is what I'm going to model and use it for forecasting and prediction. And I'll show you how Holt-Winters method of smoothing is used for forecasting, right? I'll show you how the different parameters are used, so on and so forth. So that's what I've entered over here. So seasonality period is equal to 4, and the number of observations I have is 16. So 16 is my this value over here. The number of values I have over here is 16. That is why n here, right? And the total number of periods will be n by 4. It's directly entered here. It's generally, since I assume it to be periodic, it's going to be 16 by 4 or 16 by p, right? Hope you got it. Now, since I see the number of periods is four, it is even. So I use the first approach for deseasonalizing this. I use the first approach when P is even. So that's going to be demand minus current demand minus P minus 2. P minus 2 is 4 by 2 plus demand of T plus 1. You can see I'll apply this over here. Divided by that seasonality period over here, divided by 2P. And this will always be a standardized established variable. But this, I have jotted down this formula here. So that's my deseasonalized demand. So now I have got the deseasonalized demand, but now I need a level and the trend. The initial value of level and trend. You should have known by how do I know what is the initial value of level and trend? Generally, they take the sometimes you may take the first value of level and trend as 0 and 0, or you can use some regression formula, a line of regression. How will you know what is the level of your data? So then, in that sense, I need to go for a line of regression to get the level of my data. Oh, I missed it. I'll show you how. And This was my chart. So what will be the level? The level will be somewhere over here, right? This will be my level and this will be my trend. What is actually level and trend? Tell me. If I map this to y is equal to mx plus c, what is level, what is trend? Mx plus c. What is m? Who's there? Anjali, what is m? Y is equal to mx plus c. What is m?
So I think slope is trend and y
Ah,
is level.
Y is level, intercept is level. Exactly. Good. So for this, I'll just tell you an approximate. So it can be level maybe somewhere around over here, some 30, between 30 and 40. And the trend will be a rising trend, right? Some positive value. So let slope, that is slope will be of some positive value. So how I can get that exact value also in solver. So I can go for uh, data analysis, regression. Okay. And this is for my deseasonalized data. So it's here already. So this, my y range is going to be this, and my x range is going to be this, right? And I need to choose some output where I can see my output here. I'll just choose a, right? I'll put my output here. So I get the output of my regression. So it gives me the intercept and uh, slope x variable. So I just copy this. So that is my initial level and my trend. Where is this page? Now I need to compute this deseasonalized demand based on the based on my right from my initial values. So here I need to calculate the demand based on my initial level and trend values. So that's going to be this one over here. Able to see this? My deseasonalized demand after my initial L naught and T naught. Yes?
Yes, sir.
Now I need to compute my seasonal factor. So my seasonal factor is going to be actual demand minus estimated demand. So what is my actual demand? This is my actual demand. And after deseasoning, I have an estimated demand or the deseasonalized demand. So I'll tell you why the seasonal factor is needed. You will understand once I do the actual seasonal factor, and you'll understand the purpose only if I do the seasonal factor and the leveling of the rest of the components. You will understand why you need this initialization seasonal factor. Okay. So there are four periods in each cycle, right? We saw there are four periods in each cycle, and so the number of cycles is what I call it as R. Number of periods is totally R, and number of periods in the total number of cycles I have four. Total number of seasons. Okay, so seasonality, the seasonality factor for corresponding periods or cycle is going to be based on the number of total periods I have over here. This is the approach I've used. R is the total number of periods, total periods by actual periodicity. So R is 16 by 4, that is 4, right? So R minus 1, I'm going to compute my seasonality index. So seasonality index, I'll do it here. P plus I, P is 4. So for each of the fourth component, I've added there. Got this? Clear? Divided by R, summation. Yes?
Yes,
And
sir.
now this is the seasonal factor. What do I mean by seasonal factor is for each cycle, I'm modeling for each cycle is for 4 weeks. So that's why I took 4. And in that 4, what will be the seasonal factor? Is it like this or the how the seasonality is? So that is what I have modeled over there. You can see that 0.03 and 0.05 and 0.04 again and 0.6, some kind of a seasonal factor. That factor, that peak is modeled over here in the seasonal factor. So having that, and then I go for computing the level based on the seasonal. For computing level, I need uh, level is computed using the seasonal factor and the constants. So let's see how we go about with it. For level, what is the constant we use? We use alpha. So I have alpha beta values over here. So as of now, I'm initializing alpha beta gamma to 0.5, 0.5. It can vary from 0 to 1, right? So level at t plus 1 is equal to alpha into demand by the seasonality factor plus the next one, 1 minus alpha into level plus the previous level plus trend. Right? This is exactly the same as what we did in our simple exponential smoothing. Got it? Clear? Yes.
Yes, sir.
So this will give me an error because I have not yet calculated the other seasonality factor. The other seasonality factor, when I will be able to calculate. The first seasonality factors I have initialized based on my initial seasonality factor. And then beyond this, I will be estimating based on my level and trend. Likewise, the level for this I have calculated. Likewise, I need to calculate the trend. For level, it is alpha, and for trend, it is beta, the expression over here. This is simple exponential smoothing, Holt exponential smoothing, Holt Winters exponential smoothing. Right? Got it? So now I'm going to compute the trend. So it is beta into LT plus 1 minus LT is the previous one. LT plus 1 minus LT plus 1 minus beta is going to be 1 minus beta again. 1 minus beta into the time trend again, T. Right? Now I need to stabilize. This is going to be a constant all over. Right. Okay, so I'm done with the level and trend. Now I'm ready to calculate my rest of the seasonality factors. So rest of my seasonality factor is here. No, sorry. Seasonality is here. So level, trend, and seasonality. Simple exponential smoothing, Holt exponential smoothing, Holt Winters exponential smoothing. So seasonality I'm capturing by considering the level, the trend, and the period also. That's why I've got P over here. So it's going to be ST, the current time, and P plus 1. P is 5. So, oh, sorry, P is 4. So it's 4 plus 1. It's going to be 5. Got it? That's why I'm here. 1, 2, 3, 4, period, 4 plus 1. Got it? So here it's going to be 1 gamma into. So what's my gamma? Gamma is here. What is t value here now? What is t value here? What is T? What is P? T is 1. So, no, T, the initial time. So, time plus 1. So, it is 4. I'm considering T to be the initial one. So it is 4 plus 1. So, here, ST plus 1 will be the 0th plus 1. Right? Got this? I'm showing my screen here. How can I show you this? Analyze this. So, P's value is 4 here. So, it is 4 plus 1, 5. So, T is 0, right? T0 implies the first one. That's why I put F3 over here. 1 minus gamma into the previous thing. Got it? So see, the period is 4. 4 plus 1, 5. And seasonality for the, I'm calculating seasonality for the first seasonal factor. Right? So for the first seasonal factor I'm calculating. So it is P plus 1, which is 5. And that's why I'm here at S5. Right? And then it is T plus this is demand and LT plus 1, that is B3 by G3, which is the initial one, plus the 1 minus gamma into the initial one again. So this is the first seasonality I'm calculating with respect to this seasonality. I'm calculating with respect to this seasonality. I'm calculating with respect to this, likewise, and so on. That's why it's going behind the 4 periods. This is P. Got it now?
Yes, sir.
Right. And this is gamma, M is an established variable, and demand by level. Oh, am I going wrong? Okay. So I have calculated the seasonality factor, and done. Now I need to calculate the forecast. Why am I not getting this? Okay. Done. So I'm ready to calculate my forecast. Now what will my forecast be? Here, the first one. Level plus trend into seasonality. Forecast of T plus 1 is going to be level plus trend into seasonality. So far, so good. Clear till here? Do you have any doubts about the different components in the time series? Are you clear what are the different components at least? Why we use alpha, beta, and gamma to model the level, trend, and seasonality based on period? Clear till here?
Yes, sir, it's clear.
Yeah. So let's throw away both of these people now. Now it comes to the time of we are focused with some values. We are focused with the demand, right? This is like I have used the training data to do a forecast. Got it? Already I have the demand here, but I have used the training data to I have used the training data to do a forecast. And my forecast started with the estimate, level, and trend, L naught and T naught. I have done the forecast. Now I can compute the forecast error. So this is my training or validation. Based on that, I have computed the forecast. Now what will the error be? What is the
Forecast
error?
minus demand.
Yeah, forecast minus demand. So that's going to be. So how do I forecast for the future? How do I forecast for the future? The same method applies, but here, so my forecast is going to be based on one level and one trend. Okay, so YT minus the L minus one level. So this forecast here, so the forecast I'm going to do over here is based on these two values. Yes, this entire forecast that I'm going to do is going to be based on this value. That is why we have modeled level, trend, and seasonality. So the forecast I can do at any point using level, trend, and seasonality. I need all the three for doing my forecast. Got it? The purpose of all this drama here. Right?
Yes,
It's
sir.
not a simple linear regression that I do over here. So that forecast is going to be level, level plus the one into trend is T plus L. So it is this one. Okay, here am I. This formula here, you can see my mouse. Ft plus 1, my forecast, is based on the previous level, the previous trend, and that seasonality at T plus 1. Right? Seasonality for T plus 1 is what? Go to my paint diagram. Seasonality at this point, from where will I model seasonality? Based on this point. The seasonality for this point will be based on this point. The seasonality for here will be based on this. Got it? Yes or no?
Yes, sir. Sir, but why aren't we considering the previous error before forecasting for the next one? We are only considering level, trend, and seasonality, but we've also calculated error. Why can't we include that while
We have
calculating the
not
next one?
calculated. We have not. I shouldn't have done error by now. Wait. We have not come to error. I'm coming there. We are not using error for now. Right? I'll come to that. So I calculated the forecast, and I'm also doing the forecast. And this forecast, sorry. So this is based on these two things are going to be stable. What's this? So you see here, this is there should be an L over there that I have missed it. So here this is for the second level, and this is for four. This is for each of the periods. So you'll see here it is 1 into these two values and seasonality. This is 2 into the same into the seasonality. 3 is the third level and 4 is the fourth level. Right? So this accounts for the seasonality factor here and this level. Right? Now coming to error calculation. Now I hope this will answer your question. I3 minus now from here also I can do that, which you asked, right? I can have that one also, but anyway, any means of doing that doesn't make a much difference. Like adding an alpha factor from here and training the system again and forecasting the error. And now for all these error metrics, I've got the error, and now I need to have the I will just have the error square here. We know there are many metrics, right? Mean absolute square error, mean absolute percentage error, and all that. And so I'll calculate the square of this error, and I'll calculate the absolute of this error. Okay. Absolute value of this error is. Oh, sorry, it's going to be K3. And this is going to be the absolute percentage. So this into 100 will give you the absolute percentage error. So these are the three error metrics. So this is going to be mean square error. So the average mean square error is going to be the average of mean square error. Mean square error. Hope you can understand what I'm doing, right? It's very trivial. Yes?
Yes, sir.
Average of mean absolute error. What I'm doing here, this is here. Mean absolute, mean square, mean absolute, and mean absolute percentage. The averages of all these three errors I'm taking here. So finally, this is going to be average of now. What is my entire goal of all this process? What can I model in order to minimize my error? So here I can modify only alpha, beta, and gamma, which are parameters that can be used for changing my error values. So you can see here like 0.1, 0.2, and 0.8 or some values between 0 and 1. So my error value may decrease, or if you have everything as 0.5, 0.5, 0.5, and 0.5, this is the error I get. So let me make note of it so you'll know that. So for these values of alpha, beta, and gamma, I'm getting this. Suppose if I have for these values of alpha, beta, gamma, I'm getting this. Where is it, man? Paste values. Okay. So these are the different error values I'm getting for different values of gamma. Dear students, well, this is alpha, this is beta, and suppose I'm going to have an error function. How many times I've taught you this diagram? Alpha, beta. So there's going to be some value of alpha and beta where the error is going to be minimal. Right? You understand this? Loss function. I need to minimize my loss or error. Understood this or not?
Yes, sir.
W0, W1, weight of a neural network, or the constants or the variables of a linear regression. The same story comes over here also. optimize alpha, beta, and gamma to decrease my, improve my error. So this is a 3-dimensional optimization problem. What algorithm can I use here? Yes, what algorithm can I use?
Particle swarm optimization.
Great. So at least one soul told what I have taught. Right. So now I can use any of these optimization techniques to optimize it. Of course, in Excel, I don't have particle sum optimizer. I can show you how to use and optimization stuff here. So I can go to data solver. Okay. So my objective is going to be mean square error. I need to minimize my mean square error, right? This is my objective function, right? I need to minimize my mean square error, and this is minimization. By changing what all variables I can change the alpha, beta, and gamma. Got it? I can change alpha, beta, and gamma variables, right? And I'm using GRG nonlinear. Okay, all that is fine. And subject to constraints. Yeah, I already have that constraint over here. So this value can be between 0 and 1. So make the constraints non-negative. So it is going to be between 0 and 1. Already I tried this, so it's already here. Otherwise, you can add a constraint over here. We know that alpha, beta, and gamma needs to be between 0 and 1. And I'm using GRG nonlinear. Or you can use evolutionary or simple LP, or so many methods are there. So I'll keep solver solutions. So it gave me this value. So for this value, mean absolute square errors are going to be, I hope this is the minimal among all the three. Yes, I don't think you'll be getting a better value than this for our problem. So I understood at least the purpose of our optimization. I didn't show you PSO here. You can use PSO very easily. So you would have understood the purpose of optimization. You cannot randomly search for any value here. See, alpha's value, if you have a precision of 3 for alpha, beta, and gamma, then you can imagine the size of the search space. You can never land up in search space. Even now, we don't know whether this is optimal or not. Whether it landed into a local optima or did I get into a global optima, I cannot say. Right. So that's where the efficiency of the optimization algorithm. So that's it about Holt's exponential. I hope you understood the entire concept. Any questions you have for me? I'll be glad to take some.
Sir, we can in the project we can apply the particle swarm optimization on membership functions to find ABC values, right?
Yeah. Okay. That is where it is more apt. Any other questions? So I think you should be able to analyze and decode why trend. What is the role of level, trend, and seasonality in production, and what is the role of alpha, beta, and gamma in production, and how these three parameters can be used for optimizing the forecasting. Got it? Okay. So if there are no more questions, I can stop here.